Good morning, y'all. Okay, so the other day we talked about sig figs, how to use them in measurements, how to figure out how many there are using our rounding rules, and then what to do with them in calculations. All right, so today we're kind of going to extend that review whenever we talk about scientific notation because we will still be talking about scientific notation. All right, so we use scientific notation to express very large or very small numbers. Okay, so like last year, whenever we talked about Avogadro's number, all right, so we used 6.02 times 10 to the 23rd. All right, so we wrote that instead of typing out or writing out 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Instead of typing out that whole number every single time. All right, so it can be super useful. All right, so just a reminder, whenever you use scientific notation, it consists of a number between 1 and 9, followed by a times 10 to some exponent. Okay, so it's going to have that exponent. The exponent can be determined by the number of decimal places that you have to move. Okay, now one thing that you have to remember, and a lot of you forgot this last year, is that you only want one number in front of the decimal. Again, only one single number in front of that decimal. All right, so if we have really large numbers, then your number is greater than 1, so the exponent will be positive. Okay, so if the exponent is positive, then you're going to have a number greater than 1. All right, so we want to write this number 39,923 in scientific notation. Well, whenever we write it out, that decimal place is at the very end. It's understood to be at the very end. So remember, we only want one number in front of the decimal, so we're going to move it until it gets one number in front of the decimal. So our coefficient is going to be 3.9923. We're going to have a times 10, and then our exponent, again, is going to be positive because the number is greater than 1, and it's going to be the number of times that we moved our decimal. So we moved it 1, 2, 3, 4 times. So that will be our answer in scientific notation. Now, if we were to do a small number, all right, so if the number we start with is less than 1, the exponent is going to be negative. All right, so if we have the number 0.0052 and we want to put it in scientific notation, this is called standard or ordinary notation, and we want to put it in scientific notation, we're going to move that decimal to where there's only one number that's not 0 in front of the decimal. So our coefficient will be 5.2. It's always going to be followed by 10. Or times 10, and then we have to figure out what we need to do for our exponent. Well, we know that the number was less than 1, so it's going to be negative, and then the number that we use is how many decimal places we move, so it'll be to the negative third. Okay, so if we have these numbers, these are in ordinary notation or standard notation. We want to put them in scientific notation, so we're going to move that decimal. So for this one, we only want to move it over that 1. So our coefficient is going to be 9.9343 times 10 to the first. All right, it was greater than 1, so we're going to have that positive exponent, and we only moved it one time. All right, so we want to move this one 3 times. So it'll be 4.0001 times 10 to the third. it was greater, our original number was greater than 1, so we have a positive exponent, and we moved our decimal place 3 times. Thank you so much. And then our third one, it's less than 1, so we have to move it back to the right. So our exponent is going to be 3.75, always followed by that times 10. It's going to be to the negative exponent because it's less than 1, and then we moved it 4 times. Okay, so number 4, again, it's less than 1. So it's going to be a negative exponent. So it's going to be 2.34 times 10 to the negative second. And then number 5, it is greater than 1. So our coefficient is going to be 9.45771 times 10 to the positive 4th. Okay, so hopefully you know how to do that. You remember how to do that from chemistry last year. So whenever we go from scientific notation to ordinary, again, ordinary and standard notation are what that is called. You start with the number and then you move the decimal the same number of spaces as the exponent. Okay, that exponent is always going to tell you something about the number of places that you moved. Now, if the exponent is positive, then that number will be greater than 1, so you move the decimal to the right. If the exponent is negative, then that meant that the number is less than 1, so you move it to the left. Okay, so think about whenever we have quadrant rules. All right, so this is our x-axis, this is our y-axis. All right, if we were to move to the right, that's positive. So if we have a positive exponent, we move it to the right whenever we're taking it out of scientific notation to standard notation. All right, if we have a negative exponent, that means we move it to the left whenever we're taking it out of scientific notation. All right, so we have 3 times 10 to the 6th. That positive exponent tells me that I have a number that's greater than 1. So I'm going to move that decimal place 6 places to the right. So I have 3, 1, 2, 3, 4, 5, 6. Okay, so now I'm going to add zeros for all of those. So whenever you're writing this, I would love for you to go ahead and put the commas. Okay, so there's a comma after that, there's a comma after that. So this would be 3 million. Okay, so number 2, our exponent is positive, which means we move that to the right, that decimal place to the right 9 places. So we're going to have 6, 2, 6. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. All right, which is going to be, what is that, 6 billion? 6,260,000,000. Da, 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 da. All right, now for number 3, that exponent is negative, so we have to move that decimal place to the left. All right, so we start with it to the right of the 5. We're going to move it over 4 places. So that's 1, 2, 3, 4. All right, so we put in 0, so it's going to be 0.0005. All right, same thing with number 4. We have a negative exponent, so we need to move it to the left. All right, so we have 8.45. So we're going to move it over 7. So there's 1, 2, 3, 4, 5, 6, 7. Fill it all in with zeros. And there you get your ordinary notation. And then last but not least, number 5, we have 2.25 times 10 to the 3rd. We have a positive exponent, which means we move it to the right 3 times. So 2.25, we move it over 1, 2, and then 3, so we just add 1 0. So our final answer in ordinary or standard notation is 2,250. Now, the last thing that we are going to talk about is the difference between accuracy versus precision. All right, we talked about this last year in chemistry. Accuracy is how close your data is to the true or correct value or answer. Precision is just looking at all of your data. So if all of your data is close together, then it is said to be precise. All right, so if you have measured it repeatedly to get the same value or close to the same, it's precise. All right, so if we have these four dartboards with accuracy and precision, if we have these four dartboards and I want mine to be both accurate and precise, that means I need it to be to the correct answer and I need all of my answers to be close together. So on a dartboard, our correct answer is the bullseye. Okay, so we are going to get them on the bullseye and close together, so they are both accurate and precise. Accuracy without precision means that it's close to the correct answer, but not necessarily close together. All right, so it would be somewhere along those lines. Precision without accuracy means that our answers are close to each other, but not necessarily to the correct answer. All right, so you would have something like that. And then if you have no precision and no accuracy, that means that not only are you not near the correct answer, that means that you are also, like, all of your answers or measurements are not near each other either. So you would have something like this. All right. Okay, well, if you have any questions, let me know.